This video is about decision theory, which is a systematic framework for making optimal choices under uncertainty. In decision theory, we use three types of information to make a decision. The first one is alternatives. For example, in the context of farming, a farmer may have to make a choice wheat and soybeans. State of nature, which is about uncertainty and probability. This is something we don't know and it is uncertain. So for example, in farming, it could be dry season, normal season or rainy season. We don't know. Therefore, we usually assign probabilities. And the last thing is payoffs, which is usually numerical value. It could be profit or it could be cost. In decision theory, we use uncertainties and expected payoffs to make a decision about which alternative to be chosen. These are 6 types of criteria. The first one is maximax, also called as optimistic, maximin, also called as pessimistic approach, minimax regret, minimizing opportunity loss, expected monetary value, Hurwitz criterion, and Laplace method. Here is an example. A farmer has to make a choice about one of these 3 alternatives. The first one is corn, soybeans, and wheat. And here is uncertainty, which means a farmer doesn't know what type of season it would be, whether it would be dry, normal, or rainy. And within parentheses, there are probabilities. The probability for dry season is 20%, the probability for normal season is 50%, and for rainy season is 30%. And here we have expected payoffs, which is profits in thousands of dollars. A farmer chooses corn and it's a dry season, then expected payoff will be $80,000. If it turns out to be a rainy season, then expected payoff for corn would be $40,000. The objective is to make a choice out of these 3 alternatives using this information, which is uncertainty in the top row and expected payoffs. The first one is maximax, or the optimist choice. Maximax looks at the best outcomes. It's perfect for those who take risk and focus on potential gains rather than losses. So for example, if everything goes perfect, a farmer might be thinking if the season is very favorable for farming. An investor might be thinking if the stock market is moving up and up. That would be called as maximax, or the optimist's choice. We have this data. Here we have our alternatives: corn, soybeans, and wheat. This is probability, and these are expected payoffs. The maximax criteria will focus on the maximum value, and the maximum value in these 9 values is 150. 150 is the highest value. So therefore we will choose this one. And the formula that we'll use is this one, which means maximum value of out of these 9 values, which is 150, and therefore the choice will be 150, which is soybeans. The next criterion is maximin, the pessimist's approach. If you split this word maximin, it means maximum of the minimum, or in other words, best of the worst. Maximin focuses on avoiding the worst scenario. It appeals to conservative decision makers who prioritize minimizing losses. So for example, using the same data, the first step to calculate maximin would be to find out the minimum of each, because that is the pessimist approach. So for each alternative, we will see what's the minimum. For corn, we have 3 expected payoff under 3 different uncertainties: 80, 120, and 40. And of course, 40 is the minimum. So we will choose 40 using this command, minimum of these 3. For soybeans, 60 is the minimum. So we'll choose 60 using this formula, minimum of these 3. The lowest of these 3 is 30. So we will choose this 30. In the next step, we'll choose the one which is the highest. So maximin, which is the best of the worst, the best of these one is 60. So we will choose 60 and we will use this formula, which is maximum of these 3 values. And the maximum of these 3 values is 60, which is associated with soybeans. It means if a farmer is using maximin approach, their decision should be soybeans. The third criterion is minimax regret, minimizing opportunity losses. This method minimizes your maximum potential disappointment. You avoid worst case, I should have planted something else. So for example, here we have this data. We will make a decision using minimax regret. In the dry season, we have these options. For corn, expected payoff is 80,000, 60,000, and 110,000. If a farmer chooses soybeans with an expected payoff of $60,000, and the best possible outcome could be 110,000, from wheat, the potential loss would be 110,000 minus 60,000. So that's opportunity loss. The first step to do Minimax regret is to make a regret table. And the regret table is the one whereby in each column we find out the highest value and then subtract each value from that highest value. In this column, the highest value is 110. So we will subtract all other values from 110. So 110 minus 80, that will be 30, which is the regret. 110 minus 60, that will be 50, which means if the farmer cultivates soybeans and the best possible outcome was wheat 110, then that opportunity loss would be $50. And the last one would be 110 minus 110, that will be 0. So these are regrets. The same approach is applied here. We will find out the highest value, which in this case is 120, and then we subtract all these three values from 120. So 120 minus 120, that will be 0. 120 minus 100, that will be 20. So we have here 20. 120 minus 90 is equal to 30. This means that if a farmer cultivates corn, which gives a pay of 120, and the best possible outcome is also corn, then farmer didn't lose anything. So regret in this case will be 120 minus 120, which is 0. 20 implies that if the farmer cultivates soybeans, but the best possible outcome is 120, then opportunity loss will be 120 minus 100, which is 20. And similarly, 120 minus 90 is 30. The same logic we apply here. We find out the highest value, which is 150, and then we subtract all these three values from 150. Then in the next step, we calculate maximum regret, which is the maximum of these three values, 30, 0, and 100, and we use this formula, maximum of these three. And because the maximum is 110, so 110 will be maximum regret. In this case, maximum regret will be 50. In the case of wheat, maximum regret will be 120. In the last step, we will find out minimax regret, which means the option that minimizes your regret, because you want to minimize that regret, and therefore we choose the lowest value, and the lowest value in these three is 50. So 50 is our answer using minimax regret. When a farmer makes a decision about these alternatives using minimax regret, their choice would be soybeans. The fourth criterion is expected monetary value, or EMV. Expected monetary value is the average financial outcomes calculated by multiplying each payoff by its probability and then summing up the results. So there are three steps. One thing is that multiply each expected payoff by its probability and then add all the values of each alternative and then choose the highest one. These are our expected payoffs, and we will multiply each payoff by their corresponding probability, and probability is given in parentheses. So for example, the probability of dry season is 20%. So 80 multiplied by 20, that will be 16. So we have 16 here. 60 multiplied by 20% is 12. 100 multiplied by 20% is 22. Similarly, 120 multiplied by 50% is 60. 100 multiplied by 50% is 50, and 90 multiplied by this probability will be 45. And we apply the same process to the last column, and then in the next step we add up all these values. 16 plus 60 plus 12, that will be 88. 12 plus 50 plus 45, that will be 107. 22 plus 45 plus 9, that will be 76. In the last step, we choose the highest of these three, and because the highest of these three is 107, so that will be our answer. It means when the farmer is using expected monetary value criteria, then their decision would be 107, which belongs to soybeans. The next criterion is Hurwitz criterion, which is balancing optimism and pessimism. This criterion balances optimism and pessimism by assigning a weighted average between the best and worst possible outcomes for each alternative. Alpha 0.6, it means the decision maker is 60% optimistic and 40% pessimistic. And we use this formula whereby maximum payoff is multiplied by alpha, which will be 0.6 in this case, and minimum payoff will be multiplied by 1 minus alpha, which will be 40% or 0.4 in this case. This is how we calculate Hurwitz value. First step is to calculate maximum, which means out of these three payoffs, The highest is 120, so our maximum will be this one. I'll be using this formula, maximum of these three, and the maximum of these three is 150, so 150 is the maximum. The maximum of these three is 110, so 110. Similarly, we also find out the minimum. In this case, the minimum is 40, so we have 40. Here minimum is 60, so we have 60, and over here minimum is 30, so we use 30. Then in the next step, we multiply this maximum value by 60% or 0.6 and minimum value by 0.4 and then add them up. So using this formula, maximum payoff, for example, in this case, it's 120 multiplied by 0.6 plus 40 multiplied by 0.4, and the answer will be 88. So I'll be using this formula, which means maximum value multiplied by 60% plus the minimum value multiplied by 40%, and that gives us 88. Using the same formula, we calculate Hurwitz value for other alternatives. And in the last step, we choose the highest of these three values. So using this formula, the maximum of these three, 114. When using this criterion, our answer will be soybeans. The last criterion is the Laplace method, which assumes equal probability approaches. In this case, we determine the average payoff for each alternative and choose the alternative with the best average. So in this case, we assume that all three alternatives have equal probability, and therefore we take their averages. This is our data, 80 plus 120 plus 40, and when we take their average, that turns out to be 80. The average of 60 plus 100 plus 150 is 103.33, and this is the average of these three values. And in the last step, we choose the one with the highest value, and the highest in these three is 103.33. It means when using Laplace method, our choice will be soybeans.